Hello class, my name is Samuel Terry. This is ISA 4220. This is my presentation on Imap and DNS. So Internet Message Access Protocol, aka Imap, is an email protocol that allows you to store, view, and manage messages on the mail server. Imap runs unprotected on the standard application server. Imap operates as the gateway between user devices and the email server. Imap runs on port 143. IMAPS is the Internet Message Access Protocol Secure. It's an email protocol that basically does the same thing, but it runs on a secure server. IMAPS runs traffic through the secure socket layer. The SSL provides the user messages with encryption that prevents from data loss and unwarranted access. IMAP runs secure protocols on port 993. Dovecot is an open source IMAP server that is used for security purposes. Dovecot runs strictly on the Linux operating system. Dovecot is extremely universal and compatible with various standard groups and servers. Dovecot uses mail user agents, or MUAs, to access their mail. Dovecot has a local delivery agent, or LDA, that oversees storing user emails within the system. So to harden IMAP, you would need to use encryption. Using IMAP allows the user to secure the emails, secure the email server, make sure the server is encrypted. Making sure that the server is encrypted prevents from loss of data. Mail relay configuration. Changing the relay configuration setting prevents spammers from spamming the user mail server. The user will need to specify which IP address will relay mail. Connections and default settings. The user will need to change the settings to limit the amount of connection and authentication errors the system will allow. Most default settings will need to be changed in order to prevent backdoors through unnecessary functionalities. Access controls. The user will need to change the setting to only allow access to users after the correct credentials are entered. And abuse prevention. Users will need to set up a block and do not accept list. This will reject any emails that contain any data that can be malicious to the system. A great example of this would be to set up outbound filtering. Domain name systems, or DNS, is basically a phone book for the internet. Users can access and navigate different websites through domain names. Domain names are what the user sees in the address bar on websites. For example, ESPN, Google, Facebook, etc. Think of a DNS as the equivalent to having contact names in your phone instead of just phone numbers. So think about operating your phone and you have to remember all these numbers and remember which number equals to which person, basically. DNS provides traffic regulations by sending users to one central location and redirecting them to specific IP addresses. This prevents websites from crashing who receive large amount of traffic. The recursive DNS resolver is the computer that responds to the recursive request from a client and takes the time to track down a DNS record. It does this by making a series of requests until it reaches the authoritative DNS name server for the request record, or times out or returns an error if no record is found. The authoritative DNS server is a server that holds and is responsible for the DNS resource records. This is the server that is located at the end of the DNS lookup chain. It will respond with the queried record, resource record, ultimately allowing the web browser making the request to reach the IP address needed to access a website or other web resources. IIS, the Internet Information Services, is the web server that is used to run all HTML page and file requests. With IIS, users can share information across local area networks and wide area networks. IIS allows users to host multiple websites with different domain names on the same IP address. Bind, Berkeley Internet Name Domain, is the most commonly used DNS software. Bind has specific name servers for internal and external clients. Internal is the caching only name server, and external is the authoritative only name server. Bind has a lightweight resolver that hosts operating systems or routers. So to harden DNS, you need to hide the bind version. Attackers can easily find the version by performing a security audit. This version can be used to make the process easier for attackers. Restrict zone transfers. Attackers can try to perform a DNS zone transfer in order to have a better understanding of the network topology. Best way to prevent this is by restricting the server that can perform the function or this function. Disable DNS recursion. This setting can also increase your exposure to DNS amplification attacks. Use a DDoS mitigation provider. Mitigation services help prevent the downtime caused by DDoS attacks. These services make DNS servers secure and more responsive. And this is my works cited page. Thank you for listening to my presentation.